Let's take a look. The first one we looked at was the atom screen, and now we're going to look at the symbol screen. Make sure that you checked the stable, unstable box down here. And as we see here, we're going to be working with what's called isotopic notation. And I'm just going to start by building an atom. Notice again, review quickly, that every time I add a proton, the name changes. So again, we said earlier that protons identify the number, the actual element. Okay. This one has 5 protons. Now let's see what happens every time I add a neutron. And if you would, pay attention to this box. Every time I add a neutron, what happens? Notice that the 5 isn't changing, which should be telling us something. That 5 is actually representing the number of protons, or the atomic number. So the bottom number, bottom left or down here, is always going to represent our atomic number. Look up here and watch what happens as I continue to add neutrons to this atom. It's changing. What that means is that this top number actually represents our mass number. If we look up here, we see that we have 5 neutrons and we have 5 protons. Well, 5 and 5 is 10. So when we're looking at isotopic notation, the top number is always our mass number, the bottom number is always our atomic number. And then over here we see we've got some charge stuff going on. It's currently a +5 because, like we talked about earlier, it has 5 positive protons and there's no negative electrons to cancel out those 5 positive charges. Watch what happens to this number as I start adding electrons. And again, if you look up here, it makes sense. There's a positive and a negative they've canceled out. A positive proton, a negative electron they've canceled out. So we have 1, 2, 3 positive protons, which is why we see that +3. But what happens if I add another electron? Now I have 3 negative electrons. There's 3 positives, they cancel out. And so what we're left with here are 2 positive charges. So we're just going to keep on adding here. And now we see that it's 0. There's no charge here because if you look up here, we have 5 electrons, 5 protons, they cancel each other out. What happens if I add another electron? Now it's a -1. We have 6 negatively charged electrons and 5 positive protons. There's more electrons than protons, which is why we see that -1 right there. The other thing that I want to remind you about is that the neutrons are what makes something stable or unstable. So here we see that boron 10, okay, boron 10 is stable. We see that boron 11 is stable. Well, what's the difference between boron 10 and boron 11? Boron 10 has 5 protons, 5 neutrons. Boron 11 has 5 protons, but it's got 6 neutrons. So it's the same element, and those two guys are called isotopes. When you have 2 atoms that have the same number of protons but different numbers of neutrons, we call those isotopes. And we could go ahead and add another. And when you see right here where it says unstable, what that's telling us is that that's not an isotope that's going to occur naturally in nature. If we wanted to make sure we've got that neutral atom also, we could bring that back down. Let's take a look at carbon. Carbon on the periodic table has 6 protons. So I'm going to add 1 more proton, and now I have carbon. We see that this is carbon 12 because it has 6 protons and 6 neutrons. 6 plus 6 is where that 12 comes from. And remember, this bottom number down here represents the number of protons. So we see that carbon 12 is stable. Here's carbon 13, 7 neutrons, 6 protons, it's still stable. Carbon 14, it appears, is unstable. Okay, so really we only have 2 isotopes, carbon 12 and carbon 13. Key thing to remember, they're both carbon. Okay, there's carbon 13. I take away a neutron, it's still carbon because I didn't change the number of protons. Isotopes are when you have the same number of protons but different numbers of neutrons.